Alright, so for today, we're going to continue doing VIWAC, the word problems, but now we're going to do it with inequalities. So just to review really quickly, you should have picked up this page for the warm-up, and we'll go through these really quick. So this first one, if x is less than 7, the only thing we need to do is put our number on the number line. This would be an open circle with an arrow to the left. The next one, x is no less than -4 and at most 5. No less than really says that x is greater than -4, and if it's at most 5, you're really saying that x is less than or equal to 5. Can both of these happen at the same time? Can a number be greater than -4 and less than or equal to 5? Yes. So what that means, we need these two numbers, and x is going to be somewhere between them. That one right there has an open circle. That one would be a closed circle, and we go in between. Okay? Same idea with these. If I solve this, I would solve it just like a normal. So I would subtract 3, get that -8x is less than 2. I would divide by -8, remembering that when I divide by a negative, that symbol gets flipped. So this really says x is greater than -1/4. And it does say to graph the solution. So if I were to do that, I would have my number line. I have -1/4. It would be an open circle to the right. We have the compound inequality here. So my first step is to separate it. So I would have -2x minus 28 is less than -3x. And I would also have -3x is less than or equal to 32 minus 2x. And I'm going to solve each of those separately. So I would add 2x to both sides, get -28 is less than -1x, divide by -1, flip the symbol, so x is less than 28, and do the same thing here. Let's add 2x to both sides, and get -1x is less than or equal to 32, divide by -1 so that x is greater than or equal to -32. And again, I ask myself if those two things can happen at the same time. Can there be a number that's less than 28 but also greater than -32? Yes, there is. So we have -32, we have 28. That's an open circle and a closed circle, and we shade in between. So just recalling some of the stuff about inequalities and solving them, and then we move into some of the word problems. So if the perimeter of a rectangle is between 15 halves and 21 halves, what are the possible integer values of the perimeter? Remembering that integers do not include decimals. So if this is really 7.5 and this is really 10.5, what are the possible integers we could be talking about between this and this? Well, that would be 8 or 9 or 10. Okay, those are your possibilities for your perimeter. If the width of a rectangle must be less than 8 1/6, name 3 possible integer values for the width. So basically, if we talk about x is the width, okay, and then we look at, well, I want to create an inequality that says that x is less than 8 1/6. Okay, and again, it's saying possible integer values, and it wants 3 of them. So that means that x could be, well, it could be 8, it could be 7, it could be 6. It actually could be 5, 4, 3, 2, or 1 also. So you have different possibilities here. The real question is, could it be 0 and could it be negative? Okay, so if you keep in mind, things about inequalities are mostly about interpreting that final answer that you get. Sometimes we put it on the number line. Sometimes we just choose numbers that make sense based on the inequality itself. All of that will be necessary when we go to solve word problems. Okay, so if you go to the packet now, on this packet, let's start with the front where we talk about the symbols that we're going to use. All right, so these, of course, are the 4 inequality symbols. This one, of course, means less than. And I don't know, you can think about this being is smaller than. And this is what makes inequalities in particular, is the word than right there. Okay, so this one is greater than. We could also think about it of is more than. Okay, and then we get to these. Of course, this one is that should have a sign right there. This one be is less than or equal to. But don't forget the ones that are a little bit tricky. This one is also at most. That's the one that people usually forget. And it also means no more than. No more than actually means less than. Okay, and then we can follow the same idea here, where this one is greater than or equal to. Along the lines of at most, this one is at least. And then we could think of no less than. Okay, so just some key phrases that we definitely need to think about. All right, so if you turn the page and we simply, so here's some basic examples. You know, I'll look at number 2 really quick. 7 increased by 3 times a number is at most 28. The reason I wanted to look at this one was because of those words right there. So I'm going to let x be a number. Okay, and now I'm going to write an inequality. I have 3 times a number increased by 7 is at most. Well, back on the front, I had mentioned that at most really means that's the highest it can go, so it would really be less than or equal to 28. Okay, so don't forget there's our v. Now we're not writing an equation, we're writing an inequality. We would still do the work to solve this, so we would get 3x is less than or equal to 21, divide by 3, and get that x is less than or equal to 7. So here is your work. So our answer, well, with this one, the number can be 7 or lower. Okay, so the number can be 7 or lower. The check for this one is kind of silly, but at this point we would just do a number line with a closed circle going to the left. Okay. Number 4 is much the same. A number multiplied by -5 is no more than 39. So again, I would let n be a number. Okay, and then I would try writing my inequality. A number multiplied by -5. So I would write that as -5n, and added to 9 is no more than. Again, really means it's going to be less than or equal to 39. And then you could do your work and your solve and graph your number line. Okay? So notice that so far anyway, the inequalities are not really working any differently than the regular equations did. You just might have something else to do at the end. Okay? So if we turn the page and take a look, just really quickly, number 1. By the way, if I'm going too fast, feel free to pause this and you can do some work and then replay it or play it after you're set. Rewind it as often as you need to or anything like that. Okay, so Chris works as a carpenter and earns $35 per hour. He pays his helper a flat amount of $55 each day that he works. If Chris would like to earn more than $225 today, how many hours will he need to work? So with this, we are definitely looking at let x be What do you think X would stand for here? Okay, well, that's what this was about. So it's the number of hours Chris works. Okay, that's it. That's what we need to know. So now we write our inequality. What we do have to consider here is that Chris is the one earning the money, but he pays his helper some money. So Chris earns $35 per hour, but then he's going to pay his helper, so which means that he's losing $55. And that's for the day, so we don't need a variable there. He wants to earn more than $225, so that would be greater than $225. Okay, so now we solve this. We have adding 55 to both sides. We get 35x is greater than 280. Divide by 35. And x is going to be, let's see, 280 divided by 35 is 8. But notice it says x is greater than 8. So when I write my answer to this, please make sure to say that Chris must work more than 8 hours. Keep in mind that if he actually works 8 hours, it won't be enough. This says it has to be greater than. So when I do the check, I'm actually going to pick a number bigger than 8. And because this one is about working per hour, I'm going to use whole numbers. So I'm going to check 9. So I'll do 35 times 9 minus 55. Okay, 35 times 9 is 315. If I do 315 minus 55, I get 260. And now I ask myself, is 260 greater than 225? And in this fact, it is. Okay, so I hope that makes a little bit of sense. Okay, so let's skip down to number 3. When this video is done, you can go back and try and do number 2 based on what we did with everything else. So in number 3, the cost of a telephone call is 60 cents for the first 3 minutes, plus 17 cents for each additional minute. What is the greatest number of whole minutes of a telephone call if the cost cannot exceed $2.50? Okay, so this is where being specific really, really helps. I'm going to let X be the number of additional minutes. Okay, so now when I write my inequality, it's 60 cents for the first 3 minutes, and then it's going to be 17 cents for each additional minute. And I want that to not exceed $2.50, meaning I want it to be less than or equal to $2.50. Okay? Now this shouldn't be a very difficult thing to solve, so I subtract 60 cents. I get 0.17x is less than or equal to $1.90. I divide everything by 0.17, and this gives me x is less than or equal to 11.1764 . Okay, well, this is where interpreting the answer is so important. If x is less than or equal to 11.1764 blah 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 blah, then what can x actually be? Would it make sense to use a decimal in this case? It really wouldn't, because it says whole minutes. Okay, so that means that the answer is 11 additional minutes. I hope that makes a little bit of sense. We wouldn't use decimals in this case because of the idea they want whole minutes. Now, the other thing to pay attention to is that X stood for the number of additional minutes. This asked for the entire phone call. So don't forget what this right here really represented. The 60 cents was actually the first 3 minutes of the call. So the total call is 14 minutes long, if that makes sense. And that's the longest that the call can be made if it's going to cost $2.50 and no more. Okay? To do a check on that, just check 14. All right, or well, check 11 for the x. Okay, so if I did 0.60 plus 17 times 11, well, 17 times 11 cents is $1.87. $1.87 plus 60 is $2.47. And so now again, you would ask yourself, is $2.47 less than $2.50? In fact, it is, so it checks. Okay? If you could now please turn to number 7. In number 7, Mr. Policha has $50 in his pocket to buy breakfast for his advanced algebra class. He buys 3 cartons of orange juice at $2.29 each, and then wants to buy donuts with the rest of the money. Donuts cost 70 cents each. What is the greatest number of donuts Mr. P can buy? Okay, so once again, what is it we're looking for? We're going to let D be the number of donuts. Okay, and now we need to write our inequality. We are going to buy 3 cartons of orange juice at $2.29 each. So we have 3 times $2.29. And then we're going to buy some donuts worth 70 cents each. So we have the 0.70 D. He has $50. Can he spend $50? Yes. Can he spend more than $50? No. So that means that we're going to have this be less than or equal to 50. It'd be awesome if he didn't have to spend 50, which is why we would do the less than. Okay? So take a minute and solve. Pause this while you solve and then come back and see the answer. Okay, so 3 times 229 is 687. Subtract 687 from both sides and get 0.70D is less than or equal to 43.13. Divide by 0.7 and get that D is less than 61.61 blah 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 blah. So how many donuts would that be? Well, that would be at most 61 donuts. That's a lot. Okay? So make sure you interpret that answer at the bottom. Should we have decimals or not? And then you can do the check on this yourself. Okay? All right. Let's go to number 9. Number 9 is a really good one. Students very often get confused with this idea of averages. Okay, so there are 5 exams in a marking period. Ian received grades of 70, 78, 90, and 95 on the first 4 exams. What grade must he get on the last exam so that his average is at least an 85? So we've seen a question slightly like this before. Think about how to do average. You add everything up and divide by how many there are. So we need to know this 5th exam. So we're going to let X be the score on the 5th exam. Okay, and then we write our inequality. Well, if we know that average is adding everything up, so I'll do 70 plus 78 plus 90 plus 95. And then we have this last one, so that's plus X, and we would divide everything by 5 for the 5 exams. We want his average to be at least an 85. Okay? Now we have to solve this. I would add everything up together. When I do that, I get 333 plus X over 5 is less than or equal to 85. And now I would multiply by 5. Multiplying by 5 gets rid of the fraction, so this would give me 333 plus X is less than or equal to 425. Subtract 333 from both sides, so that X is less than or equal to 92. Okay, so that means, so Ian must earn at least a 92%. Okay? All right, let's move down to number 10, which is a little bit trickier because of some things that it says about this. So first, the lengths of the sides of a triangle are consecutive even integers, which means that we're going to be doing x, x plus 2, and x plus 4 for our first, second, and third sides. Okay. And then it says the perimeter must be at least 12 and no more than 24. So when we actually create this inequality, it's going to be a compound. I know I'm talking about perimeter, so I'm going to do x plus 2 plus x plus 4, and then it gets a little bit tricky from there. Really important about this one is the idea that this is at least 12 and no more than 24. At least means that it's greater than or equal to, no more than means it's 24. So what we're actually going to do is create a compound inequality so that the perimeter is trapped between 24 and 12. I hope that makes a little bit of sense. So now what we're going to do is solve this compound inequality, but first I'm going to simplify this to 3x plus 6 less than or equal to 24. And just like we did on the first sheet, if you remember how to solve the compounds, we have 12 less than or equal to 3x plus 6, and we have 3x plus 6 less than or equal to 24. Solve both of these separately. Subtract 6. 3x is 6, divide by 3, so that x is greater than or equal to 2. Subtract 6 so that 3x is less than or equal to 18, divide by 3, so that x is less than or equal to 6. So what this really means is that 2 is less than or equal to x, which is less than or equal to 6. X is between 2 and 6. What becomes really important about this question, and where I am going to end with this, is remember that x stood for the first side of the triangle. Okay, so what I actually suggest you do for the answer of this question actually has multiple answers. Okay, so remember that we're talking about a triangle. A triangle has 3 sides. So I'm going to say first side, second side, third side. And this is actually, when I create this little chart, this is how I do my check at the same time. So remember that x stood for the first side. The first side, according to this answer, can be between 2 and 6. Keep in mind that we were doing even consecutive integers. So the first side can be 2, or the first side can be 4, or the first side can be 6. That is really, really important that these all stand for the first side. Now, if the first side was 2, the second side was 4, and the third side would be 6. If the first side was 4, the second side would be 6, and the third side would be 8. But if the first side was 6, the second would be 8, and the third would be 10. Okay? Now right within this, let's do our check and make sure that it actually works out. So if I'm looking for perimeter, so if I'm looking right here, my perimeter would be 2 plus 4 plus 6, which is 12. Right here, my perimeter would be 4 plus 6 plus 8, which is 18. And here, my perimeter would be 6 plus 8 plus 10, which is 24. See how the perimeters are trapped between 12 and 24? The lowest is 12, the highest is 24. That means I check. Okay? This is the one that I really want you to pay attention to. And I'll tell you that the same kind of thing happens in number 8. When you go back and do number 8, there are multiple answers. All right, please give these a try. The rest of this packet is your homework and the rest of your classwork. I'll see you on Monday. I'll be here early if you have any questions. Bye-bye.